So, here is equation balancing podcast number 3, and this one is a little tricky. I didn't want to baby you. I know you're better than the other two that I gave you, so I figured I'd give you a little bit of challenge. Now, this is a reaction in which we produce not two products like we have before, but three. We have potassium carbonate, and I'll go ahead and underline those. That's potassium carbonate. And we have phosphoric acid. This is the same kind of acid that you get in Pepsi and Coke. Now, we produce three products. We produce potassium phosphate, we produce water, and we produce carbon dioxide. So, since this is a gas, you would probably see a lot of bubbling as a result of this reaction. So, let's get right to it. Now, we've already got the correct formula, so step one's done. We've already arranged the reactants on the left and the products on the right, so number 2 is done. Now we need to make a grid. And again, I'm going to go ahead, and if I see ions on both sides, I'm going to go ahead and keep them together. So in this case, we can't do that with carbonate because there's no CO3 on the other side. We can, however, do that with the phosphate ions because we do have a PO4 here and a PO4 here. So I'm going to go ahead and use that to my advantage and have one less thing to worry about. So, we have potassium, we have carbon, we have oxygen. Now keep in mind that's going to be the oxygen that's not a part of phosphate. We got to count our PO4s separately. Then we have hydrogen, then we have our PO4, our phosphate. So, we're good to go. Now let's go ahead and make our initial count. So, we have 2 potassium on the left with that subscript of 2, and we have 3 potassium on the right. That's going to be tricky. So, now we have carbon. We have 1 carbon on the right, or 1 carbon on the left, and 1 on the right. So that should be good. Now, the oxygens that aren't in phosphate, we have 3 as part of potassium carbonate on the left. We have 1 in water and 2 in carbon dioxide for a total of 3 on the right. So we're balanced there. We don't want to mess with that unless we have to. Now we come to water. Not water, but hydrogen. We have 3 hydrogen on the left, and we have 2 hydrogen on the right. And finally, we come to our phosphates. I don't see any subscripts. I don't see anything in parentheses there, so I'm going to assume that we have 1 phosphate on each side. So most of this is already balanced. However, we've got that whole pesky 2-3 situation going on. We have an imbalance in potassium, and we have an imbalance in hydrogen. So we've got to figure something out there. Now, this is one of the trickier situations whenever you're balancing equations, when one side has an even number of atoms and the other side has an odd number of atoms. Now, the rule I always follow to make my life easier, and I would highly recommend that you do as well, make the odd numbers even. Now, in the context of balancing equations, where the only thing you can do to change anything is to multiply by a coefficient, what coefficient will get you an even number? That would be 2. So, go ahead and put a 2 in front of the number that's odd. So in this case, we're going to go ahead and put a 2 right here in front of potassium phosphate. Bam. So, now, keep in mind that putting a coefficient in front of a compound changes everything in that compound. So, we now have not 3, but 6 potassium atoms. We now have not 1, but 2 phosphate ions. So we've got to keep track of this stuff as we go. Because remember, adding a coefficient changes everything. So, now, we're in pretty good shape. Now, in order to balance potassium on the other side, obviously, what times 2 gives you 6? I believe it's 3. So we're going to add a coefficient of 3 in front of potassium carbonate. 2 times 3 is 6, so we have 6 potassium atoms on the left side of the equation. Now, again, adding a coefficient changes everything, so we've got to go through and make sure that we keep track of that. So, in the case of carbon, we multiply by 3, and we have 1 times 3, or 3 carbons on the left. And when it comes to oxygen, we have 3 times 3, that's the subscript there, so we have 9 oxygens on the left-hand side. So that's something clearly we're going to have to address in a minute. So let's go ahead and backtrack a bit, because really after each step you need to check whether or not you're balanced. Clearly, since we've been keeping really good track of our atoms, then I would really recommend that you use this grid, especially as you're getting used to things and for harder equations like this. Let's go back and fix carbon and oxygen if we can. So in the case of carbon, we have 3 carbons on the left, and we have just 1 on the right. But luckily, we have only 1 compound that has carbon in it, just carbon dioxide. So I'm going to make this easy, and we're just going to add a coefficient of 3 in front of CO2. Bam. So we now have 3 carbon atoms, so carbon's balanced. We now have, outside of phosphate rather, we have 3 times 2 is 6 oxygens, plus the 1 in water gives us 7 oxygen atoms. That's going to be a little tricky, but let's see what else we need to do. Because clearly, we're good with potassium, we're good with carbon, but we need to fix oxygen and hydrogen. Now it just so happens that we have a compound that contains hydrogen and oxygen, water. So that's probably where we're going to want to go with this. Now again, the rule is always to make the odd numbers even. So, in this case, the odd number is 3. And how do we make an odd number even? We double it. So, I'm going to add a coefficient of 2 in front of phosphoric acid, H3PO4, and I'm going to multiply. So 2 times 3 gives us 6 hydrogens. And we now have not 1, but 2 phosphate ions on the left. So, phosphate's good. Carbon's good. Potassium's good. All we need to do now is figure out oxygen and hydrogen. And it looks like that should be pretty easy. So let's first tackle hydrogen. That seems like something that would be pretty easy to do. So, hydrogen, we have 6 hydrogens on the left, we have 2 on the right. Now, what would we have to do to give us 6 hydrogens on the right? Of course, since each water molecule has 2 hydrogens, we'd have to multiply that by 3. So I'm going to go ahead and add a coefficient of 3 in front of water. Now we have 6 hydrogen atoms. And now we have, let's count the number of oxygens. We have 3 times 1 is 3, plus 3 times 2 is 6 from carbon dioxide. And that gives us 9 oxygen atoms. So, if I'm not mistaken, I believe that balances our equation for us. Now, this is an example of one of the more difficult ones you'll ever have to encounter. So, if you didn't follow along with this just yet, practice makes perfect. This does take practice, so don't think that just by watching these podcasts it's just going to soak in. Now, your job is to go and practice and get some help from me to make sure that you understand the material. So, hopefully this will help you get started, and thanks for listening.